In this question, we are doing this T-piece diagram in orthographic projection. So we are doing this T-piece in orthographic projection. This will be the front view, this will be the side, and this will be the plan. This is gotten accurately from the diagram itself, which you can see there. So it means if we view it from direction A, which is from the left-hand side, you can see this front. If we view it from the right-hand side, this is a first angle projection. So we are viewing it from the right hand side means we are placing the side view to the left. So for first angle projection, if the side view is being viewed from the right hand side, we place it to the left hand side. Then we have the plan below it. So let's get the diagram now. All right, now to start with this diagram, we're going to start with our horizontal line. So with that horizontal line of any dimension, preferably with a T-square, but just want to use this. Now from our line, since this will be our diagram, so we can just centralize it. So we have a point. So at this point with protractor, we are going to get our 90-degree. I'm doing it like this because I'm not using the T-square. So I want to make it using my drawing materials. So 90-degree upward from this center point, 90-degree upward. Then after doing that, I will take my ruler. Then with my ruler, I will join the points vertically. Which I have there. Now, what's the next thing? Next thing is to get my marginal lines. So my margin, I'm making use of 0.5. So I'm going to start with this line. So I will take my 0.5. So 0.5. So when I do it upward, that's 0.5. And when I do it downwards, that's 0.5. So this stuff that I just did here, I'm going to apply the same thing at this other side. So at this place also, my 0.5 and my 0.5. Then I join the two horizontally. I'm sure you know about this before. It's the process of you getting your marginal lines. The marginal lines that will be needed for you to get your construction itself. I'm making the line stick so that you can be able to see it more clear, but it should be a faint line. Then I do the same thing for the vertical line 0.5 left and right, and then 0.5 left and right. I join together, then I join it together also as straight line. So I join together a straight line, and this also. Now, what's the next thing? Next thing to be done is for me to get my 45-degree. Since according to my sketch in my front first angle projection, my 45-degree will be to this side. So I will take my protractor to this center, downwards, this is first angle projection, then my 45-degree between 40 and 50. When I do that, I will now join it to the center point, and I will extend. This question that I'm doing here is from the past question, so just trying to see how it is done. Now, normally in the question, we are asked to make use of a scale of 2 to 1. Using scale 2 to 1 means you have to increase all dimensions by 2. For this place, where it is 15, that will be 100. Where it is 26, that will be what? 52. But for this construction I'm doing here, I'm not scaling it. So I'm drawing the diagram as I am given. So if you're asked to scale it to 2 to 1, that means you are going to find twice of all dimensions I use. Then if you're asked to scale it from 1 to 2, like 1:2, that means you divide all dimensions I use by 2. Hope that is clear enough. So scale 2 to 1 means you multiply everything I'm doing by 2. But what I'm doing here now is the main diagram itself. So please take note of that. Now, let me start with the front view. So initially, the front view here, there's a little space of 3 mm before we now have the total length. But now, the total length itself from the question is given. Yes, total length itself is from here is given as 30. Yeah. So which means that after the 3 mm, then we have 30. After 3 mm, we have 30. So let's see. That means I have 0.3, then 3 centimeter. So I'll mark the 2. This for 0.3, and from the 0.3, I'm having 3 centimeter. You can see that this diagram will be very, very small. So should I increase it? Should I scale it? If I scale it, no, don't let me scale it. But I'm sure you understand what I'm doing here. I'm drawing the diagram as I'm given. So if you are drawing it with a different scale of 2 to 1, that means you are multiplying everything by 2. So which means this letter that I'm using 3, we're going to use 6. But I just want to draw it with what I'm given. So I hope that is clear now. So 3 mm, then 3 centimeter. Like 0.3, then 3. I do the same thing downwards. 0.3, then from the 0.3, 3. So I join it together as a straight line. Then the other one also as a straight line. That's for 0.3 and 3 centimeter. Now next, I'm going to have 8 and 18. That's 0.8 and 1.8 from this same line. No, this is 1, 2, 3 from this same third line. So 0.8 and 1.8. This is for 0.8, and from the 0.8, we have 1.8. Then from this same third line, 1, 2, 3, we have 0.8, and from this 0.8, I'm going to have 1.8. All right, now let's join them together. So this gives us the second line, and this also gives us for the 1.8. Okay. Now from here, I think I have the vertical that I need. This diagram is very simple, so that's why I'm just trying to use the scale as I'm given. I don't want to use the. So if I'm using the other scale, that means we are multiplying everything I'm doing by 2. But I'm not multiplying in this sense. So the total height is 50, while the height from here to here is 20. So that's 30, then 20. 3 centimeter, then 2 centimeter up. So that's what I'll be doing here. So 3 centimeter up. After 3 centimeter, 2 centimeter. So that's 3 and 3 and 2. So that everything will be what? 5. So let's do the same thing here. 3 and 2. So that everything will be what? 5. So I also join together horizontally. I join together horizontally. Okay. Now I have this part now. Now before I continue, let me try to get I'm having some things here already. So let me try to get them out to make the diagram a little bit faster. Now the base. My base is not starting from here, it started from this 0.3. As you can see here, there's a little space of 0.3. Then we have 5 for the space. But initially my base is starting from here to here. So 1, 2, 3, 4. The fourth line. 1, 2, 3, 4. The fourth one. So the fourth one to the extreme end. Hmm? So the fourth one to the extreme end. So this will give me my thick line. I'm trying to use a thicker pencil so that you can see it more accurately. So the first one to the extreme end. Now, then from this place, so this 3 centimeter, okay, Uh, Now after this one, trying to check for something. All right. So after this one, then I will join this together. This my 0.8. That's from here to here. Hmm? Then I will take this upward. Take this upward. Here I'm following my sketch. Now next, here we join the 1.8. Where is the 1.8? This is the 1.8 here. We will check. We have the 0.8, and after the 0.8, the 1.8. So this place will join this place. Then after that, I will join the two intersection slanting. So this place as a slant line. So that's what I'm having there at first. Okay. Yeah. So even though my sketch look like that, but according to construction, is what I want to have. Now, let me go ahead to so that's the front view. As you can see, very simple. Now let me go ahead to the side view. Now I've gotten the vertical heights, now the horizontal. I'm having 31, 8, and 31. Everything gives me 17. So 31, 8, and 31. That's 3.1, 3.1, 0.8, and 3.1. So let's get it out. So remember all dimensions, as I take it from up, I'll take it from down. Okay, let me take it on this line. Using my other pencil. So 3.1, from 3.1, from 3.1, 0.8, and from 0.8, that will be 7. So everything will be 7 centimeter. So as you can see, 3.1, 0.8, then 3.1. Everything is 7. I do the same thing downwards. Everything is 7. This 3.1. And from the 3.1, 0.8. So once I've gotten that, I join them together as a straight line. Join them together to the slant line. So I only need the intersection to the slant line. Now, after doing that, let me do the same thing for the down part, the plan, because I will also be needing it at the plan. So let me start from here. Everything is 7, 3.1, then 0.8. I do the same thing here. Everything is 7, 3.1. You can see, even using my ruler, I make sure that my ruler is well aligned. So 3.1, then 0.8. So when I join together, when I join this first 3.1, it will intersect with this slant line, specifically where this other one is meeting. When I join the other one also, the same thing will happen, the 0.8. Then when I join the last point, which is the 7 and the 7, okay, these two. So not getting mixed up with the line, with the points. So this is my 3.1 here, not this one. So now after getting, I can see the intersection. Now for this one now, I can easily get my diagram here, right? Okay. Now using my tick line, so I will join this place together. Don't mind me, I'm using this protractor. I just need a straight line, and I don't want to use the angular this time around. I join this place also. I will join the top. I join the top. Now, this one is joining vertically, but in between here is a broken line. In between here is a broken line because the shape here cannot be seen physically, but it's to note that there's an hidden line there. that been taken from the diagram itself. You can see it at the structure there. Meaning that if you read from the side view, from the right hand side, you cannot see this place. This place is to show this little part here that cannot be seen from the right hand side. But you can see this slant space as a rectangle. And will go entirely upward. It will go entirely upward. Then after that, it will join. So this for the side. So this for the front. This for the side. Now, going over to the plan. It's almost completed. Now the plan, see what we have here. We already have it as. Now, where is the top? It's starting from this place now. If you look at it from the top view, from up. So it means it's starting from here. 1, 2, 3, from the third one. This third one here to the extreme end. To 7. So we have this. Then now this one will join to this place. And this other one will join to this place. Following the sketch. Now the next part is this. Something in orthographic projection. The sketch is the most important part. Because if your sketch is wrong, then your diagram will be wrong. So the first thing to know is, how do I know my sketch? How can I read this diagram and get it accurately? So we get this part also, we join. And we get this part also. But now, that a mistake has been made. This one will not go entirely down. Yeah, that's the essence for this place. When we read the diagram from the top, this place intersects like this, right? And all the way to the end, right? But now, something now happened in this diagram. This lower part here, assuming it's extremely to the end, this place will not be necessary. But it's meeting at the center instead of at the end. So since it's at the center instead of at the end, that means we have a broken line that will come at this side. According to my sketch that you can see there. Then this one too will also be broken. So this place. So that's what we're going to have there as a broken line. What else? Then we have this place, this edge. I'm going to show it as an edge here. So this is the plan. So since this is in first angle projection, we have the symbol as this. So this is the T piece. So this is the T piece. Now let's try to add some dimensions that we used here. We have this and we have this. So dimension also has to be accurate. It's not just by doing it roughly. Now this 20, and this 30, and this what? 15, right? Now let's get this place. This and this. Now some dimensions does not need to be necessarily repeated. So because we have them already, it will be unnecessary. Now this one is 31, this 31, and this 8, everything is 70. We don't have any circle, no. Okay, what next? This part now. Okay. We have this, and we have this. Okay. From here to here is 18. From here to here is 8. And this is 26. Now this lower part, I will just show this one here to show this small place here is 3. If that small place is 3, that means this one is what? 5. Because the 2 of them is what gives us the 8 there. So I can just show them here instead of. So I should not cluster the dimension at one place. This one I already have them here, but I can still show them one more time. This place, this place, this place, and this place. So this 31, this 8, and this 31. If from here to here is 26, okay, here to here is 13, right? Mm, that means I'm not supposed to write this one here yet. Okay. Now from here to here is 13, which is this one. Yeah, this one. This one is 13. Let me write that here. Okay. So from here to here is 30. Now, what next? This little part. If from here to here is 30, okay, let's see. What's everything in total? 30 plus 3, that's 33, right? So everything in total is what? 33. Okay. I can I can do it down here. I can do it down here. So everything is 33, right? Okay. Now if everything is 33, now 26 taken away from 33, that gives us 4, 7. That gives us 7. That means from here to here is what? 7. So 7 this and this gives us what? 33. So I think yeah. So that's all the dimension we need in this T piece. So that's for that question.